visual representation of a specific situation. Go ahead and follow along with your notes. When creating a model of an everyday situation, it's important to think about how the range, now remember from our last lesson, the range is the y, changes with the domain x of the situation. So basically, how is the y-axis changing with the x-axis? Three general changes that can occur in a graph are range increasing, and this would look something like this, range going up, range decreasing, which would look something like this, range going down, and then range remaining constant, which basically means it's staying the same. And there's only a little section of this graph right here. This flat part means that it's remaining constant. It can be helpful to label the periods on a graph that are increasing, decreasing, or constant. And that's exactly what I did up here by drawing these arrows. Let's move on to the next slide. So here's the first example. Mr. Curry is out golfing and hits a golf ball. Draw a rough sketch of a graph where x equals time in minutes and y equals the height of the ball. So the first thing that I want to do is go ahead and draw my graph. And I want to label my axes. I know my x-axis is time in minutes. I know my y-axis is height. Okay, so now I think about this situation. I think about Mr. Curry at the tee. I see him hitting the ball. I see the ball going up in height. And then at a certain point, it starts to come back down. And then potentially it flattens out. So again, I said the first thing that's happening is the height is increasing. Next, the height is decreasing. And finally, the height is constant at 0. So this is the increasing part, this is the decreasing part, and this is the constant part right here. Let me go ahead and use a different color. Up, down, and then constant. Let's move on to the next example. Here's the next example. It says Principal Hamberlin gets in her car and leaves home. When she gets on the freeway, she hits traffic and has to slow down. Finally, she gets to school and parks her car. Draw the sketch of a graph where x equals time in minutes and y equals speed of the car. So again, I'm going to start off with my graph. I'm going to label this as time in minutes, and this is my speed. So, now what I'm going to do is go ahead and go through each statement and determine whether it's going to be increasing speed or decreasing speed. So Principal Hamberlin gets in her car and leaves home. When she gets in her car and leaves home, that means that her speed is going to be increasing. She's parked and her speed is increasing. Next, she gets on the freeway, she hits traffic and has to slow down. Slowing down implies that we are decreasing. And then finally, she gets to school and parks her car. Again, this means that she's decreasing all the way down to 0. So we're going to start at 0. We're going to draw something that's increasing, something that's then decreasing, and then constant, and then decreasing. You might be asking, where did this constant part come from? Well, assuming that the traffic was going at the same speed, the traffic is constant. So again, this part was increasing. This part was decreasing. The traffic was constant, and then finally it was decreasing again. Here's the next example. Example 3 says Mr. Riz lives in an apartment at the top of a hill. Draw a rough sketch of a graph from the time he leaves his apartment until he returns to his apartment at the end of the day. X equals time in minutes and Y equals elevation. By this point, you should see the pattern. We're going to go ahead and draw our graphs. My time is down here in minutes. And this time we're not talking about speed or height. Actually, we're kind of talking about height. We're talking about elevation, which means height above sea level. So I'm going to go ahead and reread this. And as I reread it, I'm going to see what's the first thing that happens, what's the next thing that happens, and so on. So Mr. Riz lives in an apartment at the top of a hill. Nothing has happened yet, but I know that my height is high. Now it says, draw a rough sketch of a graph from the time he leaves his apartment, so leaving my apartment, until I return to my apartment. So now when I leave my apartment, my elevation is going to be decreasing. Now hypothetically, I get to school and I'm at that elevation all day, so that is going to be constant. And then finally, I'm going back home, returns to his apartment, so that means that my elevation is going to be increasing. So let's say my apartment is up here somewhere. I'm going to be going down, going to be constant, and then it's going to be increasing again to that same height of the apartment. So again, this is decreasing, this is constant, this is increasing. Thank you very much, and that's our lesson for today.